Hello class, welcome to Geometry Lesson 11.1, which is all about three-dimensional figures and cross-sections. By the end of this lesson, you should be able to identify three-dimensional figures and their relationships with polygons to solve problems. Alright, so the first thing we're going to look at is Euler's formula. First of all, you might be looking at that name and saying, how on earth do you get Euler from there? If I remember correctly, this is a German name, and they pronounce EU sounds like oi. So Euler's formula. Okay, so Euler's formula talks about the relationship between the number of faces and vertices of a polyhedron and states that it is 2 more than the number of edges. So let's remember a few different vocab terms here. So if we are talking about faces on a 3D figure, let's think of just a Kleenex box, okay? All of those cardboard sides, those are considered faces of that rectangular prism shape. Vertices are like the corners, so the points on the corners of the Kleenex box. And then edges would be if you ran your finger along where it, the two faces meet, it forms an edge. Okay, so that's what I mean by faces, vertices, and edges. So in this case, this whole side here, that is a face. And then if I wanted to talk about vertices, I would talk about all of these points. And if I wanted to talk about edges, I would talk about all of these different edges. Okay? So if we look at this example, we have 4 faces, because we have, if we look at this, we have 1, 2, 3, and then 4s on the bottom. We have 4 faces. We have 4 vertices. So I'm going to say 4 plus 4 equals, and then if I wanted to figure out the number of edges, I could, in this case, simply count them. But sometimes there's going to be too many for us to count, and that's why we're going to use this formula, okay? So this is called Euler's formula. Faces plus vertices equals edges plus 2. Okay, so let's look at our first example where we apply Euler's formula. First, let's look at a couple examples that are true just to help you see this relationship. If we have a triangular prism, so when you're in elementary school, often they call it like the tent shape, right? If you take your faces and vertices, I say 5 plus 6, that should equal the number of edges plus 2. Is that true? 5 plus 6 is 11. 9 plus 2 is 11. So I know that it works there. If I try it with the rectangular prism, 6 plus 8, so faces plus vertices equals edges plus 2. 6 plus 8 is 14, 12 plus 2 is 14. So it's also true. So if you want to keep going through that table and checking, you can. Or if you want to just trust it, that's fine too. So polyhedron has 12 faces and 30 edges. So if we're talking about a polyhedron, it's a 3D figure, okay? And it has 12 faces and 30 edges. Okay, so remember, it's faces plus vertices equals edges plus 2. So I'm going to add that plus 2, but I'm missing the vertices information. So if I want to know how many vertices does it have, I'm going to say 12 plus v equals 32. Subtract 12 from both sides, and I'm left with 20 vertices. So you'll have some questions like that where you just have to calculate one of those missing numbers. It's not always going to be a vertice. Sometimes you'll solve for the number of faces or the number of edges, but it's the same idea. Why don't you go ahead and see if a polyhedron can have 4 faces, 5 vertices, and 8 edges. Good luck. Hopefully when you plugged everything in, you ended up with the faces and vertices equaling 9 and the edges plus 2 equaled 10. Since those two numbers don't equal each other, you said no. Okay, so that's all about Euler's formula. That'll be part of your assignment. The next part of this section is describing a cross-section. So a cross-section is when you take a 3D object and let's say you sliced a little piece out of it and pulled it out. We want to know what shape is that. So one way to visualize a cross-section is, let's say you have a roll of coins. So you know how sometimes at a store, if they need to make change, but they run out of a certain number of coins, or a certain coin amount, they open up a brand new roll of coins, and they pull out, let's say, one coin from that. That would be a cross-section for that entire roll, right? If you pull it out, that shows what the shape is within the roll. Okay, so another way would be if you took a basketball and you cut a slice out of the middle, you would get another circle, right? Okay, so let's say we have a figure that looks like this one. Okay, so that is called an octahedron, a regular octahedron. It means all of the sides are the same because regular, right? Then octa means 8 sides, and hedron just tells us it's a 3D shape. So what is the shape of each cross-section? So if we talk about plane M, so plane M is that bluish plane, and it slices the octahedron in half through the top and bottom vertices. So going through this top one and the bottom one, it slices it in half. And so we want to know what shape does that make. And if we look at it, it ends up making something that looks like that, which would be a rhombus, right? It's a tilted square. Then, if we looked at plane N instead, we would have a perfect square. And there are some examples in your textbook. So if you open up your online textbook and click into the interactive portion of it, there's examples where you can take this image and you can rotate it around to be able to better see all of the different angles. So that way it's easier to see that, oh, hey, this does form a square. Or, yes, this does form a rhombus, okay? Cross-sections are sometimes one of the most challenging things for students to visualize. So if you are getting really frustrated with figuring out cross-sections, that's okay. It takes practice, and just make sure you ask questions, okay? So question 2, if I asked you to describe this cross-section, so that means what is the shape of this cross-section? So you can see we have that plane cutting through that cone, pentagonal cone. What is the shape of that cross-section? Good luck. Hopefully you saw that it formed a pentagon. If you have questions at all, please be sure to ask for some help. Let's move on to example 3. So sometimes I will ask you to draw a cross-section. So let's say we have this tetrahedron. So tetrahedron, just so you guys know, it means it's a type of pyramid. It's the type of pyramid that has the triangular base, okay? So a tetrahedron is a pyramid with a triangle base. So a plane intersects a tetrahedron parallel to the base. How do you draw a cross-section? So first, you want to imagine that you have that tetrahedron and you have a plane going through it. So you can see, if I were looking at a figure, this is what I would see, right? Because you can't see through things typically. But if we imagine that we can see through it, that would allow us to see, oh yeah, it would cut through the back of the figure. And so I would be left with a shape that looked like that. And then if you remove the plane and just shade in what was left, you can see the cross-section. So you can see that it is a triangle left for a cross-section. When you're looking at 3D figures, just a couple of reminders. If there's solid lines, that means if you're looking at that figure, in real life, if you're looking at something that is this shape, you would be able to see all of the things that are solid lines if you're looking at it. Anything that is dotted means that is something that you would not be able to see unless you can see through the figure. Okay, so just a reminder that that's what those dotted lines mean instead of being all solid or all dotted. Okay, so that was example 3. Is sometimes you'll have to practice drawing a cross-section and identifying what shape it is. So example 4, what if I give you a polygon, so the 2D figure, right? Let's say I give you a triangle, and in this case, an isosceles triangle, so we have two congruent sides. If you rotate an isosceles triangle about the altitudes, remember altitude is the height of the triangle that goes through the middle, right? What three-dimensional figure does the triangle form? So if you rotate it, it has kind of 3 nice steps there to show you that, hey, as you rotate it, it becomes a cone. So this is another one of those things that if you're having a hard time visualizing it from these pictures, go into your online book. There's another interactive triangle that you can spin and see how it makes a cone. Okay, so basically this whole section, what you need to know is you need to know how to use Euler's formula. So faces plus vertices equal edges plus 2. You need to know how to describe a cross-section or draw it. And you also need to know what happens when you rotate polygons, okay? And all of these things just take practice. I think you guys will catch on to Euler's formula pretty easily, but cross-sections and rotation of polygons can sometimes be a little tricky. Be patient with yourself and ask questions. Have a great day.